You know those logical paradoxes that feel like glitches in the universe? Ideas that seem to just break reality? Well, what if they aren't flaws in logic at all, but are actually powerful tools that expose the hidden flaws in our own thinking? Today, we're going to crack that code. Yeah, I know, it sounds completely absurd, right? But believe it or not, for some of the greatest minds of the 20th century, this wasn't just some fun thought experiment. No, this was a terrifying possibility. They realized a single perfect contradiction could bring the entire temple of math and reason crashing down. This is the story of that very real threat. All right, so to really get a handle on this, we kind of need a map. And the official story, the map that everyone used for decades, was first drawn up way back in 1926 by a philosopher named Ramsay. This was the accepted way to navigate these tricky waters. So Ramsay's map basically splits all paradoxes into two big camps. On one side, you've got your logical paradoxes. These are the ones that pop up from pure abstract math concepts, things like sets and numbers. And on the other side, you have the semantic paradoxes, which are all about the weirdness of language and meaning, the classic "this statement is false" type of thing. For decades, this was the accepted view. But here's the kicker. What if this map is actually leading us in the completely wrong direction? Okay, so let's zero in on the prime suspect in this whole story. We're talking about the most infamous so-called logical paradox that seriously threatened to break mathematics itself. Let's meet Russell's paradox. And the setup for this is, well, it's deceptively simple. I mean, we all know what a set is, right? It's just a collection of things. The set of all planets, the set of all books on your shelf, easy stuff. But the philosopher Bertrand Russell, he imagined a very, very peculiar kind of set. Think about it. Most sets are pretty straightforward. The set of all apples, for instance, isn't an apple itself, so it doesn't contain itself. Simple. Well, Russell zeroed in on this one specific idea. He cooked up this special set, a collection of all the sets that are just like the set of apples, all the ones that do not contain themselves. And this is where your brain starts to tie itself in a knot. Okay, follow me on this. If this special set contains itself, well, it can't, because its own rule says it only includes sets that don't contain themselves. So, it must not contain itself, right? But wait a second. If it doesn't contain itself, well, then it perfectly fits its own rule, which means it should be in the set. It's a perfect, inescapable contradiction. So you might be thinking, okay, that's a neat little brain teaser, but why was it so terrifying? Well, it's because of something in logic called the principle of explosion. It's a fundamental rule that says if you can prove just one contradiction, that something is both true and false at the same time, then you can prove anything, literally anything. That the moon is made of cheese, that 1 + 1 = 3, the whole system just collapses. And you have to understand, this wasn't just some dusty academic puzzle. This was a ticking bomb at the very foundations of certainty. If Russell's paradox revealed a genuine contradiction inside logic itself, then all of math, all of science, everything we've built on reason was resting on a flaw that could render it totally, utterly meaningless. But what if everyone was looking in the wrong place this whole time? To crack this case, we have to bring in a crucial piece of evidence, the difference between pure logic and applied logic. Think of it like this. Pure logic, over here on the left, that's like the engine itself. It's the core, unbreakable rules of reason, and we've proven that they're consistent. Now, applied logic, on the right, that's what happens when we start tinkering. It's when we bolt our own parts onto that engine, our specific assumptions and premises, like the ones used in set theory. And that's where the trouble usually begins. And that right there reveals what a paradox really is. See, it's not a flaw in the engine of logic itself. It's more like a check engine light flashing on the dashboard. It's a warning signal telling us that one of the parts we added, one of our starting assumptions, is faulty. You know what? The game of chess is the perfect way to think about this. First, you have the rules of chess, how the knight moves, how the pawn moved. That's your pure logic. It's a consistent system. Then you have your opening strategy, the specific moves you choose to make based on your assumptions about the game. That's your applied logic. Now, if your strategy leads you to some bizarre, impossible position on the board, you don't throw your hands up and say chess is broken. Of course not. You know your strategy was the problem. Okay, So now that we have this key insight, let's go all the way back to that original map from Ramsay and see the crucial detail that he and generations of thinkers after him totally overlooked. The huge critical problem with Ramsay's map is that it completely misses this vital distinction. It just throws everything into the same bucket, which is like saying a bad chess strategy is the same thing as a fundamental flaw in the rules of chess themselves. And believe me, that's not a small mistake. It has these massive consequences. Suddenly, a problem in one specific application, like set theory, gets blown up and blamed on logic itself. It's what fuels this whole myth of a crisis of logic, making it seem like our own thinking has some deep, mysterious contradiction at its core, when really we just made a bad assumption to begin with.
All right, so we've looked at all the evidence. It's time. Time to deliver the verdict in the case of logic versus paradoxes. Who's the real culprit here?
And the verdict is, there never was a crisis of logic. It was a crisis of assumptions. Russell's paradox didn't break logic, not at all. It just exposed a shaky, flawed assumption people were using in the early days of set theory. The tool itself, logic, was always fine. The problem was how people were trying to use it.
So what's the big takeaway here? What should you walk away with? It's that paradoxes aren't bugs in a system, they're features. They're like the immune system for our ideas, flagging our hidden bad assumptions so we can fix them and build something stronger. They don't break logic, they push us to be more logical. And that just leaves us with one big question, doesn't it? What fundamental assumption we all hold today is just waiting for the right paradox to come along and prove it wrong?